Welcome to The Explainer. If you are an E2 pilot staring down the barrel of recurrent training or a looming check ride, you are in exactly the right place. I'm your host, and today we're completely breaking down the E-Jets E2 Auto Throttle system, so you can absolutely ace your oral exam and your simulator sessions. Because let's face it, whether you're transitioning to the E2 or just knocking off the rust, knowing the precise logic of the auto throttle is going to drastically lower your workload in the flight deck.
To keep this super organized, just like an examiner's flow, we'll hit 5 key sections. 1. Architecture and core components. 2. AT controls and indications. 3. Critical flight modes. 4. Overrides and auto disconnects. And 5. Single-engine abnormal ops.
All right, Section 1. Architecture and core components. Okay, so picture this. The examiner leans over and asks how these systems actually relate to each other. Just remember that the Thrust Management System, or TMS, is the big boss. It lives in the processor modules. The auto throttle? Well, that's really just the muscle of that broader system. The AT physically controls the engine thrust during flight, but it takes all of its steering cues and guidance straight from the automatic flight control system. Now, looking at how it's actually built, it utilizes your classic, and yeah, you kind of just have to memorize this, dual-channel, dual-lane architecture. Every single lane is hosted in a highly specific network interface controller and processor module, and they're spread across different modular avionics units. Why? Active and standby redundancy. If one channel totally fails, the other one steps up and provides complete, uninterrupted functionality. It's a really robust design. And just to give you a good mental picture for the simulator, these electronic brains are safely tucked away down in the forward electronics bay. They're down there constantly crunching the numbers, calculating the thrust lever angle rate commands before firing those signals up to the servos in the cockpit.
Moving right along to Section 2, AT controls and indications. So, how do we connect the brains in the avionics bay to the brawn up on the flight deck? Well, you've got the AT button right there on the guidance panel on the left. That's what you use to arm or engage the system. Then, over on the right, you've got the physical Thrust Control Quadrant. That houses the actual servos moving the levers, plus your manual AT disconnect switches sitting right on the outboard sides of the handles.
Now, here's a massive trigger to remember for the check ride: the dual personality of the TO/GA switch. Think of it like it has 2 totally different jobs depending on where the plane is. If you press it on the ground, it arms takeoff mode and instantly kicks on both flight directors in a dual independent configuration. But push it in the air, you're initiating a go-around. The throttles aggressively advance, and it immediately generates a flight path angle command for your vertical axis and a heading hold command for your lateral axis.
And of course, you know the golden rule. Always, always cross-check your flight mode enunciator. You'll see your engaged AT modes pop up on the left side, but keep a close eye on that green source selection arrow in the middle. It's a really critical scan item because it reminds you exactly which primary flight display is actively feeding data to the auto throttle.
Okay, Section 3, critical flight modes.
This right here is the meat of the oral exam. Examiners love digging into the exact sequence and numerical thresholds for takeoff mode. Say you're on the runway and you push the AT button below 40 knots. The system merely arms. It does not engage yet. It sits there waiting until you physically push those thrust levers past 50 degrees TLA. The second you cross that 50-degree line, boom, the auto throttle engages and commands your takeoff thrust limit.
Fast forward to the other end of the flight, retard mode. During the landing flare, the system takes over and pulls the levers back at a fixed rate down to idle, which is 22 degrees TLA. But here's the trick question they always ask. When does it officially disconnect? You need 2 things to happen simultaneously. You must have weight on wheels or wheel spin up, and your thrust levers have to be sitting below 24 degrees in that idle flat position. Gotta have both.
Next up, Section 4, overrides and auto disconnects.
Listen up, because overriding the levers is an absolute classic simulator trap. Assuming no system failures, you can physically overpower the thrust levers if you want to. But here is the catch. If you overpower them while they are above 40 degrees TLA, the auto throttle actually stays engaged. It fights you a little, but stays on. However, if you pull those levers back below 40 degrees during the initial takeoff roll or the AT hold phase, well, the system interprets that as a deliberate high-speed abort, and it completely disconnects.
Now, what if you don't hit the manual disconnect switches or overpower the levers? What makes the system throw in the towel on its own? You've got to memorize these automatic triggers. The biggest one, the one that is a vital safety mechanism, is the 8-degree split.
If the system sees the left and right thrust levers split by more than 8 degrees, it instantly kicks off. It'll also disconnect if you shove the levers to max, or if the internal monitor sense a system fault.
Finally, Section 5, Single Engine Abnormal Ops. All right, picture this. You are right at V1 in the sim. Worst possible timing, right? The workload is through the roof and bam, an engine completely fails. What does the auto throttle do? Do you need to immediately reach over and fight it?
The engineering here is honestly brilliant. The manual explicitly states that it does not just quit and leave you hanging. If it was already engaged, the auto throttle stays engaged. It instantly powers off and locks out the servo connected to the dead engine, so you don't get any wild asymmetric command issues, but it fiercely continues commanding the good engine for you. It basically takes throttle management off your plate so you can just focus on flying the airplane.
So there you have it. You now understand the core parameters, the exact engagement triggers, the automatic disconnect thresholds, and that incredible single-engine logic. The key is trusting your system's knowledge and respecting the automation. When you walk into the simulator for that check ride, are your hands going to be nervously hovering over the disconnects, or are you actually ready to let it fly?